Hello, I'm Rod Elmore, and today we're going to deal with half angle and double angle trig formulas. We're just going to deal with these at a very basic level. Can you evaluate them? And so if we take a look at this particular problem, we're going to be doing two of them. They're both a little different. Reading this problem, read this over, find the exact value of the sine of 2x. Whenever you see exact value, you know you can't use your calculator. It's not going to help you. So we need the exact value of the sine of 2x, where the tangent of x equals a negative 5/12, and the sine of x is greater than 0. This is probably kind of a complicated one when you just look at it. So you got to do some analysis. You got to problem solve. And problem solving is a skill that the world is in definite need of. So let's take a look and see what we can do to figure out anything about this. Well, I do know from my formula sheet, I find on my formula sheet that I have a thing over here that the sine of x, of 2x, equals the sine of x cosine of x. So I can look at the formula sheet and see that. Well, the formula sheet's not exactly that. Got to sneak a 2 in here. So that's our formula. But how does that help me? Well, if I could find the sine x and the cosine x, then I would have it. But where can I find that? Well, so I've got a formula for this. I know I got to have sine positive. Secret must be in this little thing here. What does this mean? Where could this occur and this occur? Well, we best look at our little diagram here then. Let's take a look at that. Now we're just analyzing, we're thinking. We don't have it necessarily memorized what we're going to do, but we're just saying, what does this tell me? This tells me that I'm at a negative 5/12. Where can the tangent be negative at? Well, the tangent's positive here and here, so it could be negative here or here. So let's see, the tangent's negative in this quadrant, and the tangent's negative in this quadrant. So I could be in either one of those quadrants. But the sine x has to be positive, in which that eliminates this one, doesn't it? Because the sine's negative down here. So this is our place we're at. We're right here. We're in that quadrant. So this tells us that this negative tells us, along with this sine having to be positive, that we're in this quadrant. So we can build a little picture then. So we know that the angle, the little right triangle's here. Now it's a negative 5/12. It looks like the negative is on the 5, but over here, the opposite would be a positive, so that's got to be a positive 5. So the negative must be down here, negative 12. So we analyze that we're in this quadrant. It's got to look like this. And so now, can we find the sine x and cosine x? Well, let's see. If this is our angle now, this is our x. The sine is the opposite over the hypotenuse, so we need the hypotenuse. How can we find the hypotenuse? Let's see, we can use what? That's right, the Pythagorean theorem. This squared plus that squared equals that squared. Now this is one we've done before, but we'll, and this is our, let's call this our r squared. So this would be 25 plus 144 equals r squared. 169 equals r squared. So r equals plus or minus 13. But this is always going to be plus, so this ends up to be 13. So now we have the sine, and the cosine is the adjacent of the hypotenuse, so we have that. So we can evaluate our picture then. So now we'll just take that formula, the sine of 2x equals 2 times the sine of x. The sine of x is the opposite over the hypotenuse, so it's 5/13. Times the cosine of x, that's a negative 12 over 13. So if we multiply those out, let's see, it's going to be a negative on top. 2 times 5 is 10. 10 times 12 is 120. And 13 times 13 is 169. So now this won't reduce. So this is our answer. And it's the exact value. And so we found the exact value. But this problem kind of tests a lot of your problem-solving skills and whether or not you can relate back and figure out how you isolate where our solution's at. So I love this problem because it's a little bit more challenging than some of the more direct ones. So try this in the homework and see how you do on this type of a problem. There's two types that come from this section. This is one of them. It's actually the harder of the two. So we'll get rid of this one, then we'll try the next one. Now if I'm erasing this too fast for you, you can always stop your video and look over the material. That's the beauty of a video, is you can play it at your speed, back it up. If you start dozing off, when you wake up, you can get back where you left off. So now let's try to find the cosine of 15 degrees. That's our goal. Find the cosine of 15 degrees. So we have to figure out how we can do that. Well, now we're going to use the half angle formula, and before we use the double angle formula. Now we have a formula, and if we look at our formula sheet, our formula says that the cosine of 1/2 of x equals plus or minus the square root of 1 plus cosine x over 2. Now can we use that to figure out what the cosine of 15 degrees is? Well, let's think about it a minute. Well, if x was 30, 1/2 of 30 is 15, so we could use that, and x would be 30, and 30 we can find. And once again, we want the exact value only. So now let's plug that formula in. So it's going to be the cosine of 1/2 of 30. Let me actually write that down. That's 15, isn't it? Is equal to plus or minus the square root of 1 plus cosine of 30 all over 2. Cosine of 30 all over 2. So now we have to figure out what the exact value for this is. Well, we know what the cosine of 30 is. Cosine of 30 is square root of 3 over 2 over 2. Now if you leave your answer like this, I don't count it wrong. I'm excited that you got that right. But you should really get rid of this little complex fraction inside that. That's just good manners and arithmetic. So we could multiply numerator and denominator by 2. And then the top would be 2 plus the square root of 3 all over 4. You can take the square root of 4, the denominator. So then this would be equal to plus or minus the square root of 2 plus the square root of 3 all over 2, because you can take the square root of 4. I like this the best, but I count them all the same. So if you just can plug it in, this is a nice little easy problem, as long as you know how to analyze the half angle and the double angle formulas. So try this on your video homework, and if you have any trouble, come back and watch the video again. Thank you.